This lesson is on types of circuits. On your composition book page that you have labeled types of circuits, you should have also written the definition for what a circuit is. A circuit is a path through which electricity can flow. You should have placed 2 post-it notes on the page. Label one post-it note open circuit and the other post-it note closed circuit. Open the flap for open circuit, and when you open that flap, on the back of the flap for open circuit, you are going to write the description for open circuit on the back side of that flap. The description for open circuit is as follows. A circuit that has gaps in the path so electricity cannot flow. The key word here is gaps in the path so electricity cannot flow. So if it is an open circuit, there are gaps and the electricity cannot flow. So if it is an open circuit, it is not a working circuit. Now underneath the flap, you are going to draw a diagram that will illustrate what an open circuit looks like. First, you're going to draw a battery. And as always, when you draw your battery, you're going to illustrate the positive end of the battery and the negative end of the battery. The negative end being the end where the electrons will be flowing from, and the positive end being where the protons are piled up. Now, electrons will flow from the negative end of a battery around to the positive end of a battery if there is a connection, a complete circuit or circle that is made from the negative end of the battery back around to the positive end. But if you notice in this diagram, there are 2 wires, there's a battery, and there's a light bulb. So all of the necessary components are present. The problem is there is a gap right here. That gap causes this to be an open circuit. So because there is a gap, this wire is not attached to the light bulb. So even though this wire is attached to the light bulb and back around to the battery, the electricity cannot flow because there's a gap. So the light bulb is not glowing. This is an open circuit. Now open your flap for closed circuit, and on the back of that flap, we're going to write a description of what a closed circuit is. A closed circuit is a circuit that has no gaps in the path, so electricity is able to flow. So an open circuit has gaps, cannot flow. A closed circuit has no gaps and electricity is able to flow. So when you are creating circuits, you want a closed circuit, not an open circuit, if you want the electricity to flow. Now, underneath the post-it note, you are going to draw a diagram, again, representing what a closed circuit looks like. Here we have the same components that we had before for the open circuit. We have the battery with the positive and negative end. We have the 2 wires, and we have the light bulb. The difference is, in this diagram, there is no gap. And because there is no gap, the electricity is able to flow, and it flows freely. So you'll notice that the light bulb is actually working here. The light is turned on. Now, because when we look at the flow of electricity, you also need to be aware of the energy transformations that are taking place. We're going to also label the different types of energy transformations taking place in this closed circuit. So you know that a battery has chemical potential energy stored inside of it, waiting to be used. That chemical potential energy, when the circuit becomes closed, will transfer into electrical energy as the electrons flow from the negative end of the battery through the wire. And as those electrons travel through the metal part of the bulb, up through the wires, and through this tungsten wire right here, that tungsten wire gets really hot because it has a resistance to the electricity. And as that tungsten wire heats up, it begins to glow, which causes light energy, the heat to be transformed into light energy, which then will transform back into electrical energy to complete the circuit.